You type a question into an AI and boom, a perfect answer just appears. It feels like magic, right? But what's really going on under the hood between your prompt and the AI's response? Well, today we're going to pull back the curtain and break down the core mechanics of how generative AI actually thinks. This stuff is absolutely essential if you're studying for a certification or, if you just want to understand the tech that's basically shaping our entire world. It's a pretty wild process when you think about it. You type in a few words, and in that split second, the AI is doing a whole series of complex steps just to figure out what you mean. We're going to follow a super simple prompt on its journey, from your screen right into the quote-unquote mind of an AI, to see exactly how it all works. All right, so first things first. Let's start with the big picture. What does the generative part of generative AI actually mean? The clue, as you might guess, is right there in the name. At its heart, generative AI is a creator. You see, while other types of AI might be busy classifying an image or analyzing a spreadsheet, this technology is all about generating something brand new. It's not just finding information that already exists, it's creating it. Whether that's an email, a chunk of code, or even a piece of art.
And that shift from just analyzing things to actually creating them, that's the secret sauce. An analytical AI organizes stuff that's already out there. But generative AI, it uses its training on these enormous data sets to predict the next most likely thing, whether it's a word or a pixel, and it effectively builds original content right from scratch. It's not just digging up a pre-written answer, it's literally constructing a new one, piece by piece.
So to understand how it builds those answers, we need to get down to the absolute smallest piece it works with. So let's talk about tokens. These are the fundamental building blocks of AI language. Now, a token isn't always a full word. And that's a key thing to get. It's the smallest chunk of language the model deals with. For example, a word like sunset might get broken down into two tokens, sun and set. Even a simple period at the end of a sentence gets to be its own token. This whole process turns our messy human language into a sequence of countable units that the AI can then turn into numbers and do math on.
Okay, theory is great, but let's make this super concrete. We're going to use this simple little phrase, a beautiful sunset, and just watch how the AI chews on it step by step.
So the very first step is called tokenization. The AI takes our phrase and just cracks it open. A is one token. Beautiful is another. Now, sunset is interesting. Because it's a compound word, the model often finds it more efficient to split it into two more common tokens, sun and set. And of course, the period at the end gets its own token too. Then each of these is assigned a special numerical ID, which is the only language the model really gets.
So there you have it. Our simple three-word sentence is now 5 distinct tokens in the eyes of the AI. And this numerical version is the launchpad for everything the AI is about to do.
Now, a model can't just process an infinite number of these tokens all at once. It has a limit, and that brings us to our next big idea, the context window. The easiest way to think about it is as the AI's short-term memory.
The context window is basically the model's field of vision. It's the maximum number of tokens, and that includes your prompt and its own response that it can see at any given moment. Anything that falls outside of that window is, for all intents and purposes, forgotten. And that's why it's so incredibly important for keeping a conversation on track. And right here, we hit a huge trade-off in AI development. A bigger context window means the AI can remember more of the conversation, right? Which leads to way more relevant and coherent answers. But processing thousands or even millions of tokens takes a ton of computing power, and that translates directly to higher costs. It's this constant balancing act between how smart you want it to be and how much you can afford to spend.
So if a model has this fixed memory limit, what on earth happens when you need it to analyze something huge like a 100-page research paper? Well, that's where our next concept saves the day, chunking.
Yeah, you hit a hard limit. You literally can't just feed a 100-page report to a model whose context window can only handle, say, 10 pages worth of tokens. The other 90 pages would just get cut off and completely ignored. The solution to this is a really clever process called chunking. Chunking is pretty much exactly what it sounds like. It's the strategy of systematically chopping up that massive document into smaller, more manageable pieces. Each chunk is small enough to fit neatly inside the context window. The model can then go through the whole document piece by piece, chunk by chunk, which lets it analyze a huge amount of info without its brain, melting.
So we've got tokens, we've got context windows, and we've got chunking. These might sound like super technical, in-the-weeds details, but trust me, they are absolutely critical to how these AI systems perform in the real world. They affect everything: the speed, the cost, and the quality of the answers you get back.
I mean, think about it. Doing chunking the smart way allows us to work with enormous documents that would otherwise be completely impossible to process. By reducing the load on the model, we get faster and cheaper results. And here's the really crucial part. By feeding the model these well-organized, contextually relevant chunks, we seriously improve the quality of its analysis and get way more accurate answers.
All right, let's pull all this together. If you're studying for a certification, something like the AWS exam, these next points are 100% your key takeaways. You're gonna wanna lock these in.
So just remember, it all kicks off with tokens. Those are the basic building blocks of AI language. The number of tokens a model can juggle at once is its context window. That's its short-term memory. The big rule there is bigger is better for quality, but it costs more. And finally, to handle anything that's too big for that window, we use chunking. That's how we manage size, breaking down huge texts into digestible pieces. And hey, this isn't just me saying this is important. The source material for this explainer specifically points out that these are core concepts you need to know for professional certifications. So this isn't just cool theory, it's the actual nuts and bolts for building real-world AI applications. So, there we have it. We've followed a single thought from a simple little sentence all the way down into the complex engine room of AI, through tokenization, context windows, and chunking. You now have a solid foundational understanding of how an AI actually reads. So the only question left is, now that you know how it works, what are you going to build with it?